amplitude, period, translations, and phase shift. These are basically the four. Bless you, bless you. He's a little shifted, I'm not sure why. There we go. It could be a fun. Oh, that's why. Because this one's so long. All right, I shifted him because there wasn't room for him over there. Okay. Amplitude, we already talked about that's the how high or the how low of the curve. Just thinking about how we can visualize that. Remember, distance between the maximum and minimum. If I do have a sinusoid, whether it's a sine or whether it's a cosine, the amplitude is only half the distance from the very top to the very bottom. And the reason it's half the distance is because amplitude says how high does the wave go from equilibrium, and similarly how low does the wave go from equilibrium. So it doesn't measure from the very top to the very bottom, it measures just from equilibrium to the top, okay? That's why it says half the distance. Period. How long or how far? I'm still just using a sine curve as an example. How long, how far means how or what is the horizontal distance to complete one full cycle. So one full cycle, that's going to be the period. The horizontal distance from the end to the beginning, from the ending point to the initial point. And that's just of one cycle. However, I'm having you guys cut the period into fourths, because when you cut it into fourths, then you can go ahead and have those other key points that help us make the graph of the sinusoid a whole lot easier. So even though the period is the distance from the very beginning to the very end, I do use quarter cycles. By just multiplying 1/4 by the period. Hold on, what did I do in the example just a moment ago, guys? How did I find the period? What formula did I use? 2 pi, yeah, you can put it that way, 2 pi over b, that's one way of saying it. So period uses the b, amplitude we know is the a from our formula. Period, I need to use the b. It's going to equal 1 over b times 2 pi, or what if I was in degrees? I wouldn't be multiplying by 2 pi, would I?
360.
Yeah, I'd be multiplying by 360 as well. So if you want, you could also say 1 over b times 360. Sometimes it's easier to think of it as 2 pi over b, but sometimes the b is nasty, and so 1 over, thinking a reciprocal is a little bit easier. That's why I put it that way. Vertical shifts shift the sinusoidal axis. So this is my d that I'm talking about. A vertical shift, oops, I should have put that underneath there. The vertical shift is going to be the d, and specifically we already wrote down the sinusoidal axis. Remember, this is like, if you want to think of it, this is our equilibrium. We're thinking about a wave, what if the lake is completely still? It's our equilibrium. Drop a pebble, then it goes up and goes down. Equilibrium only has one L, right? Let's go that way. Is it one L or two?
1 L.
1 L.
It is 2. 1.
2 doesn't look right.
2. 1.
It's just one of those words that's not going to work right. Someone has their phone closed. Check it out. Horizontal shift. That's going to be my C over B. That's going to be my C over B. And remember, the subtraction is going to be moving to the right. The addition is moving to the left.
It's 1 L.
It's 1 L. Okay. I didn't think the 2 looked right. The shift for the beginning of the cycle. Remember, our sine begins at the sinusoidal axis. Or we could say at the middle, whereas cosine begins at y equals d plus a, which we could say is at the top. Now, what if we have some sort of reflection? Is that going to maybe change things? Is it going to change both or just one? If sine starts in the middle every time and cycles up and then down, cosine starts at the top and then cycles down and then up. If we have a vertical reflection, a negative in there, is that going to change both of them? Both of their initial points? Really? If sine gets flipped, doesn't his initial point still stay the exact same? Okay. But whose initial point is going to change? Yeah. Cosine's going to have to flip its initial point. Sine's just going to stay the same, still in the middle. Does that kind of make sense? All right. So let's go ahead and get some examples and see how we do. And let's see how homework might make this tricky. Because so far, it doesn't seem easy. But if we just follow our steps, don't we kind of get to even a really nasty transformed one? So let's see what they do to make it a little bit weird. First of all, I think we have some easier examples, though. We'll come back to that if we need it at the end of class. All right, let's go here. So what if there's only one change? What if there's only one change? There we go. I want you guys to go ahead and look at all of your different characteristics. I want you to figure out what changed. All right, what do you guys figure out? What's changed? What's shifted? What's transformed?
The amplitude.
The amplitude? Nope. Amplitude stays the same. Has it shifted?
B over C. No.
No.
Has it shifted?
Just put where you're ahead. Didn't we multiply to our x?
Yeah, we multiply to our x. What happens when we multiply something by our x?
It's a horizontal stretch.
Yeah, multiplying on the inside, some sort of horizontal. Why is it a stretch and not a compression or a shrink?
Oh, I agree. It's opposite.
Because it's times 1/2, and don't we have to flip it when we think about what's going on? So if we just look at this as far as mathematically ignoring all the like, oh, hey, shortcuts 4, there's only one thing going on. It's merely a horizontal stretch by 2. Normal sine curve. Normal sine curve. It completes in 2 pi, right? But what's this one going to complete in?
4
4
pi.
pi. Normal sine has quarter cycles of pi over 2. But what are quarter cycles of 4 pi going to be? Pi. Normal sine starts at 0. No shift. All right. Cool. So does this one. Normal sine goes up to 1 at the first quarter cycle mark. Cool. So will this one. It's just been stretched. Instead of this happening at pi over 2, it's going to happen times 2 at pi. Normal sine, second quarter cycle, is back down in the middle. Next quarter cycle down at -1. Next quarter cycle in the middle. I technically did not necessarily need all my little shortcuts, but here's what I want to show you. You could have used them. Another way of writing this is y equals 0 plus 1 sine of 1/2 x minus 0. Pause. Do you agree? 0 plus 1 sine of 1/2 x minus 0. Why did I write it like that? Well, what's the sinusoidal axis? Y equals 0. What's the amplitude? 1. So I'm going to go up 1 and down 1. Do that and you can bring this down just a little bit. So that's my equilibrium, my sinusoidal axis, that's y equals 0. This is my amplitude. What would I have done with my 1/2? What would my period have been? 2 times 2 pi. Hey, look! I'm going to finish one cycle in 4 pi. What are my quarter cycles going to be? We ended up doing that just thinking about the horizontal stretch by 2, but some of you might not have thought of doing that. The only other thing we have to do before we can ever start graphing is talk about our initial point. Where's our initial point going to be? At 0, and since it's sine, it's 0 and the sinusoidal axis, which will be 0. Oh, cool. 0, 0. Mark everything by pi's. At 4 pi it needs to complete, and let's go ahead and quarter cycle. Go pi up, pi middle, pi down, pi back up. Got it. This one, though, you might have just thought of the normal sine curve and been able to be as familiar with that as you are with x squared or y equals x or absolute value of x and transform them. But you could also use our tricks. You just have to rewrite the function to see all of the different pieces in.
Can you restate where we got the period from? 2 times
Oh.
pi? I know the 2 pi.
Because b is equal to 1/2, and period is equal to 1 over b times 2 pi. So I take the reciprocal of b times 2 pi. So the reciprocal of 1/2 is 2. So I flip b and then I multiply by 2. Okay. Could have done it 2 different ways. Both ways are valid. Both ways get me to the final wave I'm supposed to have, right? What about this guy then? Can you rewrite him? There's a lot more going on. I'm not so sure that we want to try to do this one just by being familiar with sine. How could you rewrite him?
Wow.
To figure out all of our characteristics. Let me give you a second. You can talk about your groups. How would you rewrite him to see all of our characteristics? Ooh, look at your formulas. Remember how we wrote 2 different versions of formulas? One of them had yuckiness inside and one of them factored it out. Maybe factoring it out might be a great idea. I'll go ahead and freeze the screen. I'm going to write it how I would rewrite it.
No way. It's not sarcasm.
Consideration.
Frog, it's irony. It's not taste.
Might have gotten off a little bit in my space. You guys ready as to how I would rewrite it? What do you think?
Yeah.
Why did I put a 0? Who's that one that's way in front? D, the sinusoidal axis. There's no number being added or subtracted. Being multiplied, yes, but not added or subtracted. Minus 3 cosine. I pulled out my b because I wanted to see him apart from everybody else. Plus, then I nicely see my c over b. So I like factoring it out. It makes it a little easier for me. So what can we say before we even get down to the graph? Where's my sinusoidal axis? At y equals 0. What's my amplitude?
Negative.
Up 3, down 3. Ooh, negative. I'm going to circle that. What trig function am I working with on this one? Okay, so I'm going to take the cosine. I'm going to say, you know what? Cosine needs to start up. That's normal cosine. But wait, I have a negative. So couldn't I right now say if I have a negative times this guy, it's going to be a vertical flip? I'm actually going to, instead of making that guy, I'm going to go bottom, middle, top, middle, bottom, right? I'm going to go the other direction. I can vertically flip my cosine. That's the cycle I want to get a graph of. What does my b tell me? I can use it to find my period. So let's plug in b. 1 over b times, so the reciprocal of 2 pi is 1 over 2 pi, right guys? Times 2 pi. Oh, the period's 1, there's not even a pi there. And then what's my initial point? or my shift going to be? Ooh. Careful. -2. How did Patricia figure out that 0 is also a part of that point, or the actual point? -2, it's, okay, x minus c over b. It's the opposite sign, -2. X equals -2. How'd she know? It starts at, ooh, careful. It doesn't start at equilibrium. Sometimes it's hard to fill in the y. It's actually not going to be 0. Hang in there. If it was sine, it would be 0. Not cosine. -3? Oh, let's see if you're right. First of all,
That's probably.
let's graph y equals 0, yeah? Think like handwriting lines. He's the middle one. You guys used to trace your like alphabet when you were learning like printing, right? This is the middle line. This is the middle one. My upper guidelines, I'm going to use my amplitude to say, hey, from that still lake, if the pebble gets dropped, I need to go up 3, down 3. Goes up 3. And down 3. Cool. Have our handwriting lines for our sinusoidal wave. What do you think I should mark next? The initial point where I start from, or the period, how far to go from the starting point? What would make more sense? Where to start, or how far to go from start? Yeah, I better put down where to start before I can measure from start. So we have to skip the period for a second. Initial point. All right, I need to make this graph, which means I need to start with my initial point at the bottom. I know x has to equal -2. You might wonder why I'm making these so big, but maybe you'll figure that out in just a second. What is my initial point? -2, and what does my y need to be? -3. Because the cosine needs to start displaced, and usually it would be amplitude plus sinusoidal axis. Usually it would be up, so 0 plus 3. But in this case, since it's been flipped, I have to do 0 minus 3. Does that kind of make sense? Or if you just use your graph, you can say, okay, I know I need this, so I need to go ahead and start on the bottom bound or on the lower bound. And then you can fill in the point later. So I have my point, -2, 3. Why? Has anybody figured out? Why did I space those? It's just -2. Why didn't I put it like right here? What's the big deal? Each period is 1, which means in one tick mark, what do I need to have completed? 1 full cycle. Question. We did not think about one characteristic that would have helped you if you made your 2 just be 2 little tick marks. We did not think about our quarter cycles. How often are we going to have our key points? 1/4. Oh, we have to go by fourths? We're not going by ones, we're going by fourths. So if you go by a half and a fourth and a fourth and a half and a fourth and a fourth, every fourth is going to be a new key point. If I squished in my -1, -2, man, I'd have a little like, but now I can say, oh, I spaced it out. So -2 is here. Where am I going next? I'm at the lower bound for cosine. Follow the flow. I'm at the bottom. What's the wave going to do as it ripples out? Because at the bottom, it's going to now go to the, not yet, the middle first. Has to pass through the equilibrium. Then it's going to go to the top. Then it's going to come back down to the middle. Then it's going to flow back down to the, there you go. It's waving, right? Follow the flow. They didn't specifically give me how much of this cosine to show, but if I was to keep going, where would I go next? This is -1 now. Where do I go next? Middle, then top, middle, top. And you keep on going as long as it happens. Usually it's good to have at least one cycle sometimes too, to get a good representation of what's going on. This one's weird because it's been shifted way over. Questions about characteristics, about things I put on the graph, about where I got numbers from. hopefully my system at least allows you to break it down piece by piece and not have to feel overwhelmed with, oh, stink, I have a flip and I have a stretch and I have a, I don't even know, pull up the 2 pi, I have a horizontal dilation and a, this just lets us pick out these key characteristics. The quarter cycles let us know how far to get to the next key point. So I think the 5 key points, if I get those 5, I got it. Connect them, let's go. But the one thing I do want to show you guys is technically in the order that we did it. We did rewrite it first. We rewrote, that was step 1. We thought about our sinusoidal axis 2, our amplitude 3. We had to mark our initial point 4, but we had to think about our quarter cycles, technically to be honest. We had to think about our quarter cycles to know how to put the tick marks on our graph. Then we marked our initial point. Then we dealt with how long to make it. So the weird thing is you kind of think about period for the quarter cycles, mark your initial point, then come back to figure out how long or how far to make the rest of your graph. Not that that's like a step order that you have to memorize, it's just that's the order we did it in. So what do you guys think for this one? Let me see how many more examples. The rest is like homework help. Oh, I had one more nasty picture. Alright, cool kids in your groups. Let's keep going. If we have time, we'll come back to him. He's another sketching one. There are some that are way more interesting. For instance, let's think about this guy. I'm going to freeze the screen real quick. I want you guys to get as accurate of a picture as you can. Be careful. The Y tick marks are super obvious. 1, 2, 3, -1, -2, -3. What are the X tick marks? Measured by half pi. Ooh, sketch it as precisely as you can, because we need to figure out exactly where this cosine has peaks and valleys, maximums and minimums, or else how on earth are we going to figure out an equation that will fit this graph? So sketch it as precisely as possible. Maybe even label more X tick marks than they did. And maybe start thinking, can I fill in any of those pieces of the equation from what I see? Could be a cosine, but if you're thinking about it, maybe it could be a sine too. But according to the directions, well, you know, it could have been a sine. What do we have to make it? If you guys think you have one, has anybody actually started filling in stuff yet? If you think you have one, how can you check it? Go to Radian and see if it looks the same. If you're zoomed in on a, this would be negative pi. This would be negative 3 pi over 2. This would be negative pi over 2. Pi over 2. You can make your window negative 3 to 3 for y min, y max, negative 3 pi over 2 to 3 pi over 2 for x min, x max. Be in Radian mode. But for those of you that are still like, wait, what? We're trying to fill in. They told us it had to be cosine, so can you see the D? Can you see the A? Just a quick heads up, there's more than one answer. Because if you think about coterminal angles, how sine or cosine comes back to be the same thing, maybe your phase shift could be a lot of it. Okay, so checking on the calculator was for those who already had gone ahead and thought they had an answer and was kind of chilling, thinking maybe they had it right, maybe they didn't. For the rest of us, though, I'm just wondering, were you able to identify anybody? What do you think? Raise a hand if you think you have something to fill in. Kevin has one. What do you think?
You find the amplitude.
Okay, how'd you find that?
I find the lowest point and the highest point.
Lowest point is at?
-2.
Okay. Highest point is at? So how does that help you find the amplitude?
Okay.
how did he get 2 if the whole distance is 4? Yeah, cut it in half. Remember, it's from the, oh, hey, it's from the middle. So someone else, if Kevin's like, hey, it goes up 2 or down 2, what does it go up 2 or down 2 from? What would D be?
0.
0, because it goes up 2 from 0, down 2 from 0. Okay, cool. So D is 0. We have our cosine. B has to do with period. But we can't do the period until we figure out where to start, because we need to go from start to end for the period, right? So start, hold on, initial point. Has anybody found what they think is a starting point?
-3 pi/4.
Well, -3 pi over 4 would be right about here, which is down. Which we could start down on a cosine if we flip him, if we put a negative by that 2. Or we could try to start at an up, where cosine normally starts. So we could try this guy, or we could try, what about that guy? He looks approximately like a halfway point for pi over 2. So you guys think your unit circle was half of pi over 2? Oh, no. Not finding the cosine, finding the angle, pi over 4, right? Half of pi over 2, a 45 degree. So if we start at pi over 4, if we start at pi over 4, how long until it, I don't see the full circle there. Can I go the other direction? Yes, so where would that be? Is there another way to do it? What if we go from here to here, which is only a half cycle, right? Can we figure out this distance and multiply it by 2? Ooh, okay. So this is pi over 4. So I can actually draw my line straight, which obviously I did not do. Okay, this is pi over 4. What's this one going to be over here? Ooh, 5 pi over 4. Do you guys agree with Kevin? So it looks to be halfway in between pi and 3 pi over 2. So I have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Oh, okay, yeah, 5 pi over 4. So that's going to be 5 pi over 4 minus pi over 4. So what's my period, guys? Yeah, 1 pi technically, right? So that'd be 4 pi over 4, which is just pi. So do I just plug in pi and I'm done? What's the formula for period? So if I need to find b to plug in, don't I have to plug it into 1 over b times 2 pi? Right.
I thought if we were only finding half of it, then we were supposed to do times 2.
We had too much fun. When I subtracted, how much of my entire cycle did I find, guys? So if that's half of it, we're still going to come back to the 1 over b times 2 pi to find our b. What Ryan's saying is that this is only halfway. This is only my half period. So if my half period is pi, then what's my whole period? 2 pi. Oh wait, what was multiplied by 2 pi to get 2 pi? So what's my b? This one. Because remember, our cosine would have to be continuing on. Good job, Ryan. Would have to be continuing on. I need double that in order to get to the entire period, which would be the whole thing. So I found halfway to be pi, so the whole thing would be 2 pi. And nothing got changed then. A normal period is 2 pi, so there was no horizontal dilation. So at the end of the day, to make this all nice and pretty, I can say y is equal to 2 cosine of x minus pi over 4. But we had to look at how high is the highest, how low is the lowest, where is the halfway in between point for the sinusoidal axis, how high is it from the middle to the top, or from the middle to the bottom to get the amplitude. Where is the starting point? They told us cosine, so I'd start up top. Or Colby, you could have done yours back here if you had done the negative cosine. and then solve. So that's kind of nasty, in the sense that they gave you a graph and asked you for a trig function. They could give you words, but to be honest, guys, the words are actually kind of easier. So let's not stress about the words. It's actually one of the easier types. You just kind of fill in the clues. We already summarized. Let's get rid of that page. Here's the last thing I want you to write down. In a word problem, you might be asked for frequency, or you might be given frequency. So I just want to let you guys write down somewhere. Just thinking about word problem applications, write down a quick little clue. Frequency is the one characteristic that we didn't talk about because you don't really need it to graph, but in word problems it's important. Frequency is how many cycles per 1 unit of time. So instead of saying like, oh, every 4 units on the x-axis, you're going to have 1 cycle, it's like, oh, well, for every 1 unit, you're going to have 1/4 of the cycle. It's kind of talking about speed in a sense. Frequency, how often will you have a cycle? Sorry, period is how often you have 1 cycle, or how long 1 cycle is. Frequency says how many cycles in 1 minute. So just do 1/period, just the reciprocal of your period, which you guys already have a formula. Alright, we'll get to see how you do on homework. Most of it is graphing. I think we have like 1 word problem at the end. Most of it is graphing. Oh, I didn't remind everybody. Sorry, got questions. Thank you for saying something. It's on the board, but I didn't remember. Do tomorrow by the end of the day, just in case that helps a little bit. If you can't come in today, you can come in tomorrow also.
That was just all around tough. It just was. It's bad.
Go rest.